Valerio Merli from Italy, if I remember, has a question. What's the role of the binding agents? For example, can humate binding make more available micronutrients, especially in high pH soil? That is a very complicated question. I don't know if you realize the complexity of that question, but I will attempt to answer it. Before I even start, I'm going to let you know that I do not consider myself an iron expert in turfgrass science or soil science. Okay, it is immensely complex. The redox reactions with iron in the soil are complex to an extent it's almost unfathomable. However, I'll try to do my best to answer that question more pragmatically. The answer to your question is, can humate binding make the elements more available, especially high pH soil? The answer is yes, they can. Okay. The availability of iron is dictated by the solid phase of iron in the soil solution, but that's influenced by organic ligands. Okay. So the chemistry of the iron at different pHs and different oxidation states in the lab, we know the chemical reactions and what should take place, and what should remain soluble and not soluble at various pHs and redox potentials. But when you go into the field, you're dealing with a lot of organic ligands that change that. You're dealing with dissolved oxygen that changes that. So the presence of organic materials like humic acids, like you mentioned humates and so forth, the presence of those in the soil, what occurs is the iron will use, or the humates will use iron to oxidize the humates. In the presence of organic material, the iron can become more soluble because it's oxidizing some of the organic material and in turn reducing the form of iron. It's going from Fe3 to Fe2 as a result of the oxidation of organic ligands in the soil. Even in the presence of oxygen. So when there's dissolved oxygen in the soil and there's organic ligands in the soil, the dissolved oxygen will bind with iron preferentially. It will oxidize with iron first, but it will still be reduced in the presence of organic ligands as well. It's immensely complex that changes at each pH. But the short answer to your question is the presence of organic ligands will reduce the Fe3 to Fe2 and in turn result in a greater portion of the iron in the soil solution being soluble than when the organic ligands are not there. Okay, that's about as far as I'm comfortable going with it, because I just can't express it enough. It is unbelievably complex. Okay. Most of the iron will become insoluble, as I'm going to show you in the third or fourth paper from now, even in soils with large amounts of organic matter, even in soils that have little organic matter, all these things, low pH soils, it'll still be oxidized pretty quickly within a day or two. But strictly speaking, the answer to your question is yes. Ligands and organic bindings with organic materials will render the iron more soluble as a result of its ability to reduce the iron from the oxidation of the ligand. It's complicated, okay? And I may be wrong. I know the concept is correct, but my explanation might not be exactly accurate. So if I'm incorrect and there's a soil scientist who deals with iron and is listening to this and going, this guy's crazy, well, post it in the comments and I'll pin it.